3.4, we're taking a look at product to sum and sum to product formulas. And all the formulas are at the very top of your paper for this one, and they're the last, I think they're the very last ones on the sheet that you'll be able to use like for the exam. So the first one, product to sums, look like these. You'll see that we have products of cosine and cosine, sine and sine, or sine and cosine. If you take a look in your book, they'll give you two formulas for the sine cosine ones. There's no need to do that, so I'm not doing that. Because if I wanted to know what cosine times sine was, all I could do is just flip it around and it's the same thing, right? Because multiplication is commutative. So I don't need extra formulas. 3 is enough. All right, so cosine, cosine, sine, sine, or one of each. The sum to products, though, I do need 4 of them. So these are the 4 sum to product identities. So we have the addition of sines. We have the subtraction of sines. We have the addition of cosines. We have the subtraction of cosines. And you can see that they're all similar, right? Like I end up with 2's in all of them at the beginning. I end up with either sines or cosines. I end up with addition of angles, and I end up with subtraction of angles. So these are easy to get confused. So make sure when you're using one, you look at the right one because they're all really similar. And they're easy to sort of flip around if you're not being careful. Okay, so let's take a look at how these work. We're going to express this, and they usually will tell you how they want you to change it, right? It's telling you, you can see it, but it tells you this is a product. And you should see that this is a product, right? There's no pluses or minuses between anything. It's sine of theta times the sine of 2 theta. It says to express it as a product, express the product as a sum or difference. So it's wanting us to turn it into a sum or difference. Okay, so there are 2 signs that are being multiplied, which means I'm right here. Make sense? This says I'm going to have a 1/2 in the front. So I'm going to go put my 1/2 in the front here. Then I'm going to write cosine. I'm going to put a bracket. I'm going to write a cosine. It says I'm going to subtract alpha minus beta. Okay, so they're just in order. The first angle minus the second angle. So our first angle is theta, minus our second angle is 2 theta. And then it says I subtract. I've got another cosine, and my angles are added. So this is now the cosine, and the angles are added together. So this is a strict application of taking the pieces as they are and putting them in the right places. Got to be able to do that to start with, or everything else kind of falls apart afterwards. We don't get to leave it like this, right? Like we should be able to clean this up, and we will. So that's our next step. The 1/2 in front will stay 1/2, of course. What happens when I have theta minus 2 theta? You get negative theta. Very good. We'll deal with that in a second. What happens when we have theta plus 2 theta? You get 3 theta. Okay, everybody good so far? All right. We have one more set of identities that we have looked at that we haven't talked about in a little while called even-odd identities. We talked about them way back in chapter 1, I think, actually. Cosine is an even function, and even functions mean that when we have a negative angle, it's the exact same thing as having a positive angle. So the cosine of negative theta from our even-odd identities is exactly the same as the cosine of positive theta. And I'm just going to leave these angle or parentheses off of this now because I don't have any negatives or any sums or differences, so they're not really necessary. The only thing we're going to do at the very end of this is we're just going to distribute the 1/2 through. So writing this as a sum or difference, the way it was described, this is 1/2 the cosine of theta minus 1/2 the cosine of 3 theta. Okay, is that all right? Chloe, you look confused. Okay.
Would you not subtract cosine of theta and cosine of 3 theta?
Yeah, so because they're different angles, we can't. Okay. So it's like saying, well, what if we did, cosine of 45 degrees minus cosine of 30 degrees? It's not cosine of 15. We can't just subtract the angles themselves. Yep. Also a good question because it's a tendency we would have to somehow want to collapse this down, but it won't. Okay, let's do the problem in reverse now. Now it's asking us to take something that is a sum or difference and to merge it back into a product. So that's the second set of formulas that we had, right? Over here, sum or differences turn to products. So the one that you have written down there has subtraction of cosines, which means we're down here at the bottom. It says I'm going to have a negative 2 sine, and then there's going to be another sine. The angles are added, and then the angles are subtracted. So we'll go piece by piece. So it says I'm going to have a negative 2 sine. Okay, that's what it has here so far. It says the angles are supposed to be added and divided by 2. So added, I've got 5 theta plus 3 theta divided by 2. I've got sine again, right? And then the angles are subtracted and divided by 2. Okay, this is sheer application, right? Just taking the pieces and plugging them in, plug and chug kind of thing so far. And then we're going to clean it up. So if you have 5 theta plus 3 theta, what do you get? 8 theta. And what's 8 theta divided by 2? 4 theta. Okay, next one. I have 5 theta minus 3 theta. That would be 2 theta. And 2 theta divided by 2 would be theta. And we would be done. This is now a product, which is what was requested. Okay.
You can add those because they're just like thetas, right? Like there's no.
Do you mean inside of here?
Yeah.
Yes, we can add these together because they are just angle measures. It's just like having an x or any other variable, so we add like terms. If they had signs in front of them like they do down here, now we no longer can because these are like having you can kind of picture having numbers underneath radicals or something like that, right? They don't actually combine at that point. Okay, we're going to do one more and then we're going to stop for today, so you guys are going to end up not having to have 2 assignments tonight, which is just lovely. All right, this one actually have angle measures, and we're going to find a number at the end. Okay, so this is slightly different than the ones before. So it says express the sum or difference as a product. So that part's the same as the first part of the directions in the last problem. But then it says, if possible, find the value, and we will be able to do that on this. Okay, so this is sine and sine added. So if you look over here, sine and sine added, we're up here at the top. Okay, so it says, if I have sine and sine added, this is a number 2, and it's a sine. Okay, so we have 2 sine. It says the angles need to be added together, divided by 2. So that's just like the last problem we did, isn't it? So 75 degrees plus 15 degrees divided by 2. Then it says we need cosine, the angles subtracted and divided by 2. So cosine, angles subtracted, so 75 degrees minus 15 degrees divided by 2. All right, what's 75 plus 15? 90, and 90 divided by 2 is 45. Familiar angle, right? How about the other one? Cosine, 75 minus 15, 60. 60 divided by 2, 30. Another familiar angle. And that's why it asks at the end that if it's possible to find an exact expression, you will, because these are values you know from your unit circle. What is the sine of 45 degrees? Good, square root 2 over 2. And what is the cosine of 30 degrees? Square root 3 over 2. Right. And then we're going to clean this up. So one of these 2's can cancel with the denominator. Square root 2 times square root of 3, those can be combined. What is that? That's square root of 6. Can be combined because it's multiplication over 2. How could I check to make sure that this is right? Yeah, you can verify the decimal in your calculator, can't you? You can type in sine of 75 degrees plus sine of 15 degrees and just hit enter. And you can type in square root of 6 over 2 and hit enter, and you can compare the two decimals, and they should match if they're the same. Okay, so we will save the verifying identities for Wednesday.